So now we're going to start to get into the interesting stuff. Projectiles. Now, if you don't know what a projectile is, basically it's anything that's thrown through the air. In some video games, it's very basic. It's just a straight line, like a bullet firing in a perfectly straight line, and no physics like gravity or anything like that are applied to it. In most games, that's not the case. Somebody throws a grenade or something like that. It follows a nice parabolic arc, and it lands on the ground some other place on the screen and goes boom. Now, we're going to try and more simulate something like this, and that's where we're going to apply things like gravity and wind and whatnot. And what you can see in this quick little demo that I've created is I've created this projectile, which is just a square, and it's going to launch at an angle of 70 degrees, which is pretty high. It's going to launch at a speed of 200 pixels per second. Now, if no forces were applied to it in any way, shape, or form, that means it would move at an angle of 70 degrees, 200 pixels every second, which is fairly quickly, but not too quickly. You'll see that it scales pretty quick. It's has no wind resistance, which means it's not going to be affected, and that should not be degrees, that should be pixels per second. And gravity applies at a value of 130 pixels per second. So if it's moving at a speed of 200 on an angle of 70 degrees, but gravity only acts down, remember gravity pushes down, or pulls down, however you want to see it, at a rate of 130 pixels per second, it's going to pull it down pretty quickly. It's going to overcome this speed pretty quickly. So just to demonstrate this, I'm just going to launch it and hit the space key. Oops. And it goes up, and gravity applies and pulls it down, and then when it detects it hits the ground, it goes back to normal. So we're going to try and simulate this. Now you may say, well, that's moving pretty slow. Well, you can play with that data just by affecting things like gravity and the speed and whatnot, and you can simulate anything you really want once we get to that point. What I'm going to do is I'm going to take you through the step-by-step process of achieving these results. So let's quickly jump over to my little checklist here. So if you can get this done in general, you'll be able to create a projectile, and then you'll be able to apply that projectile to a variety of scenarios. So the first thing you need to do is, before you launch a projectile, you need to set up the projectile. So things like angle and speed. Now you saw in that demo, I actually had the user enter that information in using the WASD keys and the arrow keys. Now depending on the type of game you're doing, that may be completely different. You may be doing it maybe what direction a character's gun is facing or something like that. Or it could be how much the player is rotated. It could be anything. It doesn't even, and I keep talking about guns, but it's not the way it has to be. It could be a ball, maybe a basketball that's thrown through the air or something like that, bounces off a backboard, whatever. It doesn't really matter. If it's going through the air, it's a projectile. So the setup. Now what I've done in the code is basically I've allowed the user to enter in information and just use the keys, and every time they adjust the keys, they're either adjusting the angle or the speed by amount of 5, or they're adjusting the gravity or the wind by amount of 5. Now for this simple example, I've had gravity only affect the y direction, which is normal, but I've made wind only affect the x direction. That's not necessarily true. Wind can go in any direction in reality. But for our simple purposes, we're just going to have wind moving left and right, just to simplify the whole situation. So basically, we're going back to our old explanation of vectors. So if we go back over here, and I turn on my drawing mode, so that whole system was going to have our, where's my dude? Oops. We have our little box, and it's going to launch at an angle of 70 degrees. So that's saying 70. Now, applied to that is a certain amount of gravity. We're not sure how much, 130 pixels per second, whatever. And then applied to that is a certain amount of wind. Now, in this case, we have wind set at 0. So the actual movement is like this. Then the next update, this continues, but then gravity is applied again. So then the actual movement is like that. Oops, that should be a nice line. And then this process will continue. Gravity. And you can see that we're going to get this nice fluid arc. And it's going to end up on the other side. That is projectile motion. So when we decide to launch, we actually have to calculate this vector. This is called our movement vector, or our trajectory. And that is going to be based on the angle here and the magnitude or the speed of that vector. And we're going to calculate, let me just kind of create, erase a whole bunch of stuff here so we can go back. What we're going to do is we're going to use that vector and we're going to calculate the we're going to calculate the x and y components of that vector using its angle and its speed. So it's actually fairly straightforward. So if our vector is like this, and we know it has a speed of 200, and we know it has an angle of 70, we can just use SOHCAHTOA, trigonometry, to get our y component and our x component. Now we went over this in the first lesson on vectors, but really your y component is just going to be equal to your y is equal to 200 multiplied by sine of our angle, which is 70. So looking at this, this is our speed and this is our angle. And the x component is the same thing, but it's cos. So it's going to be 200 multiplied by cos of 70, and we end up with our x and y components of our movement vector, or our trajectory. Now what I need to mention, as it says up in here, any math that involves angles in whatever language you're working in, chances are it requires radians. So you need to convert your angle to radians first. Now that we've already covered this in class, if you forget how to do it, it's a very quick Google, you can figure it out. Okay. So this x and y is our trajectory, also known as our movement vector. Movement vector. Basically, if no other force is applied to it, this is how much it would move in the x direction and the y direction every single update. But of course, we are definitely going to apply forces to it. So on launch, we calculate the movement vector using SOHCAHTOA. And inside the code, we can see that. Where is it? Right here. So calculate launch trajectory. We take our speed, multiply it by our cos for the x, and our speed multiplied by our sine for our y. You'll notice that I put a negative here, and this is just to account for the fact that in our products, y increases as we go down. So we need to take that into account when we're actually calculating our x and y components. Otherwise, your parabola would be going the opposite direction, and you definitely would not be getting the results you expected. So make sure you have that negative value there. So that's calculating our launch trajectory. Now we also need to calculate our force vector. So basically, I don't want to have to apply gravity and wind separately every single update. That's a lot of work and it's a lot of math, and it costs time and effort. So what we're going to do is we're going to combine them now. We're going to do it once. As soon as we decide on the launch, we're going to calculate what is that application of gravity and wind every single update. So if gravity moves at a value of 130 pixels per update, okay, is it per update or per second? Whatever. 130 pixels, same unit of measure as the 200. And then wind is applied. Now we don't have any wind, so basically our resulting force vector would our force vector would have the y value of gravity. So whatever gravity is. The x value is wind. Now, in reality, if your wind is moving in the y direction as well, you would have to add on the y component of the wind to gravity. So you may actually end up with a greater or lesser strength of gravity as a result. So if the wind is blowing up, gravity is going to be reduced. If wind is blowing down, that's basically going to increase that downward force. So our force vector has an x component of wind and a y component of gravity, as we see right here. Set force vector, wind, gravity. So there is all of our setup. We've created our projectile and we've set up all the data we need to launch. In the next video, we're going to talk about how we actually update it, because it can be a more complicated process. But you have the basics now.